Hi everyone! Today I'm going to teach you lesson 13-5 on analyzing and graphing step functions. Before we start, I'm going to give you a little bit of information about step functions, so then you can try the do now. Step functions are functions whose outputs stay constant and then jump to a new constant value. Since these values are constant, there will be multiple horizontal lines on the graph of our step function. So think about it like a staircase is an example. We would have multiple straight lines for our step function. They don't always go in a pattern, like they're not always looking like you're walking up steps, but they will have that same look of all these horizontal lines. And when reading their formula definitions, it is important to pay attention to the domain intervals. So the domain intervals tell you for which x values the output applies to. Okay, so the output of 2 applies for 0 less than or equal to x less than 3. The output of 5 applies when 3 less than or equal to x or less than 5. Okay, so make sure you're paying attention to those domain intervals so that you can understand which x values belong to which outputs. Okay. At this point, I want you to take a moment and try out the do now. For part A, you're going to evaluate the following. So you want to make sure you understand where your x values fall in the step function for which outputs those x values will have. And for part B, you want to try and graph on the grid shown. Okay, so take a moment to pause the video and try out parts A and B. Okay. Part A, when we're evaluating the functions, we want to see where each of our x values fall in the given domains. So for the first question, I have my x value is 2.7. So I want to look at the domains and see where 2.7 falls. So in the first domain given, we have numbers that are between 0 and 3. So since 2.7 is between 0 and 3, our output is going to be 2. Okay, so let's try the next one. We're going to check where the function is when x is 5. So when x is 5, so I want to see where my domain is for 5. I want to be really careful here because if you notice, we have a 5 here and a 5 here. I need to be really careful to see which of those domains includes 5. So the bottom output includes 5 because we have the or equal to sign. It's 5 less than or equal to. So since 5 falls within this domain, our output will be -4. Okay, and we're going to follow that same procedure for the next two problems. So I'm going to look in my domain. I'm going to look for 3.5. 3.5 is between 3 and 5. So the output is going to be 5. And for the last question, we're looking for x is 0. So I'm going to find the domain that includes 0, which is the top part here. So our output is going to be 2. Now we're going to try to graph f of x on the grid below. So since we have a step function, we know that we're going to have multiple horizontal lines on our graph. What's most important is that we understand where our closed circles are and where our open circles are. And for that, we're going to look at the domains. Okay, so let's take a look at our domains. So for 0 less than or equal to x less than 3, we're going to start with a closed circle because we have an or equal to, and then we're going to end up with an open circle at the end because it is just a less than. We don't have or equal to. So let me show you what this is going to look like. When x is 0, so when x is 0 over here, our output is going to be at 2. Okay, so my output's going to be at 2. And for all values between 0 and 3, the output will stay 2. Okay, so I'm going to have an open circle at 2, 3, and I'm creating my first step. Okay, let's check out the next part. When we have 3 less than or equal to x less than 5, the first part of my step will be a closed circle at when x is 3, and it will be an open circle when x is 5. Okay, so for those, the output is going to be 5. So when x is 3, so 1, 2, 3, our output's going to be at 1, 2, 3, 4, 5. So we're going to have a closed circle at 5. So 3, 5. And it's going to remain a horizontal line until we reach x is 5, which is going to be right here. And we're going to have an open circle. For our final step, we're looking at the interval where 5 less than or equal to x less than or equal to 10. So since we have 2 or equal to's, we're going to end up with 2 closed circles on that step. Okay, so let's take a look at that. When x is 5, the output is negative 4. So I'm going to go to x is 5, and my output will be negative 4. So I'm going to have my closed circle here. Okay. Okay, and then it's going to remain negative 4 between 5 and 10. So I'm going to continue with a straight line until we get to 10. I'm going to have another closed circle. Okay, so this is the graph of f of x. Each part of my graph is a horizontal straight line and resembles some sort of step. Let's see the next question. So step functions can arise in the real world whenever the output to a particular function is constant over particular ranges. So for the first example, if we take a look at the title of our graph, it's called 2013 Postage Cost for First Class Letter. So let's take a look at the chart. Let's fill in the chart. If the weight is 2 ounces, let's find out the cost. So I'm going to go over on my x-axis to 2, and the output or the cost is going to be 48 cents. Now, if the package is 2.2 ounces, which is going to be somewhere over here, the output or the cost is going to be 50 cents. If the package weighs 3 ounces, I'm going to check, it's also going to cost 50 cents. So we're noticing that these 2 ounces measurements are on the same step, so they're going to cost the same amount. Let's check out the rest. I'm going to check out 3.5. So 3.5 ounces will cost us 52 cents. And 4 ounces is going to cost us 52 cents also. Okay, so as you can tell, some of these weights are going to cost the same amount to mail as another weight. That's what causes our step functions. The price is remaining constant over different intervals. So let's check out the question. If it costs Trina 54 cents to mail her letter, what is a possible weight? So let's check out the cost in cents. If the cost is 54 cents, what are some of the possible weights? So we're going to look at this interval right here. Okay, so because we have an open circle here, it cannot be equal to 4 ounces. It has to be a number that's greater than 4 ounces. So for example, we can have 4.1 ounces. You could have 4.3 ounces. You could be 4.8 ounces, all the way up to 5 ounces. So anything that you choose for this interval would have to be 4 less than x less than or equal to 5. 4 ounces is not included in this cost, but anything above it, up to 5 is. So there are many answers for this. You could have given me one answer. Number 2, the function f gives the cost to ship X pounds via FedEx standard overnight rates to Zone 2 in 2013. How much would it cost to ship a 3-pound package? Okay, so if we're talking about weight, that's talking about the X value. So we want to find where 3 pounds falls in our domain. So let's check our domain intervals to see where 3 falls. Okay, so I see over here that we've got less than or equal to 3. So for a 3-pound package, it would cost me $24.70. How much would it cost to ship a 7.25-pound package? Okay, so I'm going to go back into my domain interval and locate where 7.25 would be. Okay, so it would fall somewhere in this range because it's between 7 and 8. So the cost would be $31. Okay, last question of our guided practice before you try a couple on your own. Number 3, an electrician works at a job site at a rate of $40 per hour or any portion of an hour. He will charge you $40 as soon as he comes up to the first hour, and then $40 for the second hour, etc. So for each hour he stays there, he's going to charge you $40. Graph the amount the electrician charges C in dollars as a function of the number of hours he works. So let's interpret this. It says he's going to charge a rate of $40 per hour. He will charge you $40 as soon as he comes up to the first hour, and then $40 for the second hour, etc. Once he starts working, so the minute he comes to your house, he's going to start working, you're automatically going to be charged that $40. Okay, so let's think. We're going to find out what 40 is. So I'm going to put a circle here. So let's think for a second. If he works for 0 hours, he didn't start working at all, would he make $40? Well, the answer is going to be no. He gets no money for 0 hours. So if he works 0 hours, he does not get paid. But the moment he begins work, his rate of $40 per hour kicks into effect. So even if he works a half hour, he's still going to make that $40 up until he works the first full hour. So once he finishes working for 1 full hour, he will have made $40. Okay, so now the next hour, let's say he's working into the next hour. So now he's on to the second hour that he's working there. The second he starts to work into hour 2, he's going to make another $40. So we're going to go up, and he's going to make another $40 for any minute worked after the first hour, up until hour 2. Okay, so even if he works for an hour and a half, he's going to make the extra $40. Okay, and this pattern is going to continue. So if he only works 2 hours, he'll only make the $80. If he works a minute past it, he'll start incurring that extra $40. Okay, so for 2 hours, we're gonna have an open circle. And then for any minute past 2 hours, he's gonna be making that extra $40 up until hour 3. And the pattern is going to continue for each hour. Okay. So part B says, how much does he charge for working 3.5 hours? So let's check our graph. So for 3.5 hours, he will have made $40 for the first hour, an additional 40 for the second hour, an additional 40 for the third hour, an additional 40 for any minute past that third hour. So he's going to be making $160 for working 3.5 hours. Okay, so as you can see from this video, our step function will resemble somewhat of a step looking graph. So in this case, it looks very much like a staircase. And in the prior example over on the Do Now, it doesn't look as much as a staircase, but all of these graphs have something in common. They're consisted of multiple horizontal lines. So when you practice, you want to be really careful that you're paying attention to your domain intervals. Again, that tells you which X values your outputs are applied to. And you want to make sure that you're coloring in your circles for an or equal to, and that you're leaving them open if it cannot be equal to those values. So I want you to try out questions number 1 through 2 on the next page for analyzing and graphing practice. And please submit each page of your notes plus this practice to your teacher. If you have any questions, we're always here to help you answer them. We hope this has been helpful, and we hope you have a fantastic day.